Hello everyone and welcome to another video. Um, Today's topic is going to be about speed and velocity, two different quantities that we tend to interchangeably use in physics. It's something that confuses a lot of students. So hopefully by the end of this video, it will be quite clear to you when we use speed and velocity and what's the difference between these two key concepts in physics. So if we start by definitions, we define speed in physics as the distance an object travels divided by the time it takes for this travel to actually take place. As you can see, speed is defined based on the distance that in the previous video we looked into quite a few details, and we defined as a scalar quantity. The variable that we use as a symbol for speed is s, okay, and this is where it gets a bit complicated. Again, depending on the textbooks that you're using, you will see later on my tip to you on how to not get confused when using speed, velocity, distance, displacement, and so on and so forth in terms of symbols. The unit is meters per second, which we write first way like this, meters per second. So how many meters the object is moving per second. Or we can also write it meters times second to the minus 1, which is a mathematical approach, and we see it quite often and also in IB physics. As I said, speed is a scalar quantity, which means it only requires a magnitude to be defined, like a size, a number, and nothing about direction. Okay, why? Because it is defined through distance that we have identified already as a scalar quantity. If you want to know more about the differences between distance and displacement, please watch the previous video that we posted recently. Now moving on to velocity. Velocity is defined through displacement, okay, something different than distance. It's defined as the displacement of an object during its motion divided by the time it takes to travel that displacement. Okay, so it's quite similar as a definition. The key difference is speed is defined through distance traveled, and velocity is defined through displacement. Now the variable that we're using is v from velocity. Units are the same, meters per second or meters times second to the minus 1, and it is a vector quantity. Why? Because it is defined through displacement, which happens to be a vector quantity as well, meaning that we actually need to know the value for velocity, the size or magnitude, and its direction, the direction in which the object is moving towards to. Okay, so speed, scalar quantity, velocity, vector quantity. Now let's look at the equations and try to clear the picture a bit. So as we said, speed is defined as distance over time. For speed, in this case, we're using the symbol of s, d for distance, and t for time. And then for velocity, which is defined as displacement over time, we have v for velocity, as we said, and you will see in quite a few textbooks displacement shown as s and time as t. Okay, so now you can see the problem with s for speed and s for displacement. My tip, and you decide whether or not you implement that, is use v for velocity, okay, which is easy also for you to remember, and write the full word speed for speed. Okay, you will see in an example later on how I do it. At least if you are on IGCSE, GCSE level, problem will not be that complicated, so you can actually spend some time writing the full word. For IB, you can go with the symbols for speed and velocity. Now let's dive into some examples and see how it actually looks like. So in this case, we have a starting point. Okay, let's say that our object at time equals 0 is placed at the start here, okay, and that's the ending point, okay, and then it's going to follow this path, this trajectory. So it's going to move 5 meters up, 5 meters right, 5 meters down, and end in that location. And by the way, I just realized a mistake I've made. That's absolutely fine. That's what happens when you're quite new to this, so we'll see it together. So for this journey from start to end, what is the distance traveled? Okay, if our object has indeed followed this path, the distance is going to be 5 plus 5 meters plus 5 meters. That's a total of 15. Okay, and if this motion actually took place in 3 seconds, then the speed is going to be, as we see here, 15 divided by 3, and that gives us a speed of 5 meters per second. As you can see, no direction, just a number, always with the units, okay, which you will see me quite often highlight. At any time in physics you give an answer of any physical quantity, it always has to come with units, otherwise it makes no sense, plus it will cost you points in the exams. Okay, so anytime you give an answer, is it force, is it pressure, is it power, is it resistance, always write the units. Okay, one question that you need to ask yourself before you turn in your paper, you go question by question and you check whether or not your answers include units. Yeah, the mistake I made was that this one actually down here is cannot be 3 meters the way I drew that. Okay, if I want to be correct, so this would be 5 meters. And then now if we want to calculate, let's say we want to calculate the velocity in this scenario, okay, then we are only interested in the displacement. So as you can see here, displacement is going to be 3 meters, 5 meters. Okay, I need to change that as well. It's going to be 5 meters to the right, okay, because for displacement, remember, we're only interested in the final and the initial position of the object. Where did it end? To this side. Okay, where did it start? To the left side. What's the displacement between these two positions? It's 5 meters. So displacement is 5 meters. Okay, how long did it take for this object to complete this motion? 3 seconds. Okay, so we can safely say that the velocity in this scenario is going to be 5/3. I'm gonna change that fraction to a decimal number. I'm going to leave it as 5/3 meters per second, right? Okay, so you see how displacement comes with direction, same way velocity comes with direction, and that's the difference. You can see now in this example that speed and velocity end up with a different value, okay, but also velocity comes with a direction. It shows in which direction the object moved. Now in the second example, we have an object starting from point A and moving towards point B. Okay, the distance between them is 20 meters. Okay, so we have identified our distance, and then from that we can calculate the speed here at blue. So it's distance over time. Let's say this happened in 10 seconds. Okay, so 20/10, we have a speed of 2 meters per second. Now what about velocity? For velocity, we care about displacement. What's displacement in this scenario? The object has been displaced by 20 meters to the right. So velocity is going to be 20/10, 2 meters per second to the right. And this is an example where velocity and speed happen to have the exact same value, with the only difference that velocity actually gives us more information about the motion. So how has the object actually moved? It moved 2 meters per second to the right. So we can actually predict where is it going to be a few seconds later. But the value happens to be the same. Now another example is where we have this scenario now where the object would be moving between these points A, B, C, and D. And if we are interested in calculating again the speed and velocity, it means that we need to determine distance and displacement. So the distance for this scenario, where actually the object has started from point A and then completed, let's say, a full circle passing from A, B, C, D, and then ending up back in position A, is going to be, the distance is going to be 4 meters from A to B, plus 4 meters, plus 4 meters, plus 4 meters. So I need to add here, okay, D back to A. Okay, so I make this adjustment to my slide. So it started from point A, moved to point B, from point B to C, from C to D, and from D to A. Okay, which means it has covered a distance of 16 meters. Okay, and if this movement was completed within 16 seconds, it means that its speed is going to be 16 over 16. That gives us 1 meter per second. Now, what about the velocity? For the velocity, we only care about displacement. But the displacement, as we have discussed, depends only on the final and the initial position, which happen to be the same, which means displacement is 0, therefore velocity will also be 0. Okay, so this is an example where we can actually have speed, but we cannot have velocity when the initial and the final position of the object happen to be the same. That's quite interesting. Now, what does a negative sign, like a negative velocity, actually mean? It's very simple. Let's assume that we have this movement on the x-axis. So we have 0 on this side, 10 meters, and then we have identified the positive side moving to the right. Okay, so 0, 1, 2, 3, 4, 5 until 10, and our object starts to moving from here, let's say, to the left. Okay, so starts at 10 meters and in 10 seconds reaches the 0 point over here. Okay, we need to compare the speed and the velocity in this scenario. Now, again, speed, we care about distance. What's the distance? How much distance has the object covered? 10 meters in 10 seconds, therefore speed is going to be 1 meters per second. Easy. Now the displacement, now you need to be careful on this one. The displacement is defined as the final position minus the initial one. So what's the final position? Where did the vehicle ended up its movement? At position 0. So it's 0 minus 10. So it's final position 0 minus the initial, which started at 10, as you can see over there. So it's going to be minus 10 meters. So the velocity at the end is going to be minus 10 over 10. It's going to be minus 1 meters per second. So basically the minus sign is just showing you the direction that the object is moving towards to. So basically, if plus is to the right and you end up with the minus velocity, simply shows you that the object is moving to the left. Nothing more, nothing less. Now, last but not least, I wanted to discuss the difference between average and instantaneous, either speed or velocity. Now, the average, when we talk about the average of these quantities, we talk about the total distance or total displacement divided by the total time it traveled, okay? And when we talk about instantaneous, what matters is the speed or the velocity at one specific instant in time. It really depends only on the movement during this time and nothing else, nothing before, nothing after. Okay, so it's just one instant. And let's see that from an example which will be quite clear, hopefully. Okay, let's say that you want to take a road trip from Leipzig to Berlin, a total distance of 2014 kilometers more or less. And this trip lasted 3 hours. Okay, so if you want to calculate the average speed that you had, okay, you're going to divide the total distance, 214 kilometers, over 3 hours, and you will end up with something like 72 kilometers per hour. And that's your average speed. Was this speed constant? That's my question. Of course not, because during this trip, okay, there were areas of the trip where you were able to speed up to 150, 160 kilometers per hour, areas where you had to slow down to 0 kilometers per hour in case you encountered construction sites, which is quite often between Leipzig and Berlin. So your speed varied a lot through this trip. Your average speed, though, which again is derived by knowing the total distance and the total time of the trip, was 72. But in different instance of the trip, you definitely reached higher speeds. So basically the instantaneous speed is what your car's speedometer shows at that very specific moment in time. When it shows 135 kilometers per hour, that's your instantaneous speed. If you want your average speed, you need to calculate the total distance over the time it took, and that's the difference. That's the main difference between average speed and instantaneous speed. So in this video, we've seen the differences between speed and velocity and how we can calculate them, whether or not they're scalar or vector quantities, their units. I hope this video has been quite helpful. If so, please don't forget to share with friends, leave a comment if you have a question about it, and I'm happy to get back to you. And don't forget to subscribe to the channel, since it's a quite new channel, and hopefully I will be adding more content every week. Thanks a lot. See you until next time.